Hey guys, welcome back. Well, we got all set up. So we got these pieces of metal. You can see it's zoomed in right there. Here's another one just for reference. This is what it looks like. It's basically we just take a piece of 5-inch round bar that's cut off like 1.25 inches thick. We already machined this little rectangle on the bottom, and this is the first operation we did. This lets us grab it in the vise. So you can see it's clamped up in the vise. And we got a program wrote. And we don't know if this is really going to work. We're going to be running low RPMs with this big cutter, and I'm kind of worried. We're going to try to, this is our first main cap we're going to try to start making, and when we cut this hole in the middle, I got a feeling we're going to break something or it ain't going to work, but we'll see. For me, this is a learning experience. So anyway, with no further ado, we're going to run this and see what happens. Alright, here we go. Good luck, everybody. Oh, that looks insane. Man, it feels great to be right. Okay, so I'm not sure where we went wrong, but we did go wrong. Holy crap, that did not work. Let's see. Forgot to turn the air on for one. What happened there? I don't even know. I think it just vibrated so much our air nozzle moved. Actually, this whole thing looks like it. Huh. Alright, well, let's check this out. Here's our part. We took a big old cut, and it did not like it. Let's see if we broke anything. Surprisingly, we didn't break anything. I don't think. Huh. It was not happy though. Golly. I had a big steel plate sitting on this thing and it shook so much the whole fucking plate fell off. Look at that. Damn. Yeah, I might have to go back and watch the video. But that was rough. I wonder if it grabbed the part. It still looks fairly... Actually, you can tell. I got parallels. Yeah, these are still tight. One moved a little. Yeah, it might have moved a smidge. Still tight over there. That one's tight all the way. So, it may have moved a little, but I have this pretty damn tight, so. Yep, something went wrong, so we're going to go back and I'm sure it's just too aggressive, but let's see what we find. Alright, so I'm not sure what happened, but I'm literally just going to restart it and see what happens. We are going to pump up the RPMs a little. Something bad happened. We had an error 3.4 on the VFD alarm. So the VFD alarmed out. Well, let's take a look. I'm sure it had nothing to do with overloading it. What do you think? That's where she was when she shut off. Man, so this whole headstock was shaking like hell, so I'm pretty sure we're pushing this too hard. Evidenced by the machine shaking like crazy, and then also by an alarm that fired, which is likely, yes, I can't turn this clockwise. I can't even turn this anti-clockwise. It's totally just jammed. Oh, buried into the material. Yeah, so it's probably bending the spindle right now. Let's see. Probably gonna try lifting it up, see if we can free it. Hopefully nothing bad happens. Yep, that was probably the sound of... Yep, I just broke the carbide. Man, we're bending it. Did you see that? Funny enough, a needle in a haystack, but I just spotted that. There's the piece of carbide that just broke off. So... that sucks. Well, I don't have any spare carbide, so I'm not going to be able to use this cutter until I get more carbide in. But I think we learned something. This is way too aggressive apparently, which is weird because our test cuts went a lot better, but this didn't. So, let's see what that looks like back there. I'll hold this. Anyway, I'm not sure what this means. Obviously we just overloaded it and she stalled and then it quit, but even before it stalled, it did not sound happy. So that's what happened to our VFD. Error 3.4 and the alarm light's on. So, I'll Google it. I'll bet you anything that says too many amps. EO3, overcurrent event during acceleration. Yep. Alright guys, so one thing I do enjoy other than destroying expensive tooling is also destroying expensive tooling. So we're going to pop this one out, and I got another one and we're going to put it in, and I got to write a whole new program for it, but I think we're just going to try this again and use a smaller cutter, see what happens. Alright, so we're going to try this again. So we swapped out to the 5/8 indexable end mill, and I forgot about this carbide. I actually have spares for this. But since these are indexable, you can actually flip them around 180 degrees and you get a new cutting edge. So you may be able to tell here that on the left it looks dark and on this side it looks shiny and new. It's because we swapped them over. So anyway, we rewired our program. This is going to run at about a half a cubic inch a minute and about 600 surface feet. We're going to see how it does. I don't know. We broke stuff last time, so you know, we're kind of prepared for anything. But let's see what she do. Unfortunately. Alright, so we found another problem. Let me show you. Okay, so here's the problem. So if you look at this cutter, fire up the light, you will note this shiny mark right there. There's actually metal on it. And if you look here, you see how it was like doing this crazy nonsense? And then, here's the giveaway. Look right there. See how there's a step in this floor by my fingernail? Where when it was cutting over here, it's deeper than it was cutting there. It shouldn't have done that. What happened is, between when it was cutting here, by the time it got to this cut, the tool had dropped down in the tool holder, and it's cutting deeper than it's supposed to. And that is exactly what happened. If we look at the tool holder, see that shiny metal poking out? That tiny... where my fingernail from there up, that's supposed to be up in the collet. That moved. It pulled the tool down, probably from vibration or something. And I'm here to tell you, I tightened that pretty dang tight. I could have went a touch more, but I mean, it was real tight. So the fact that that moved, that's not good. I could put it tighter, but damn, I guess that's This is still too aggressive. You can tell the machine's shaking and vibrating, and you know these chips look awesome now. Look at this, big beefy chips. But this machine is not liking that, so it's obvious this is still too aggressive. We're gonna have to change it. That sucks, but what you gonna do? So anyway, that's what's happening. We had to stop it again. May just call it a night and kind of come back and think about this later, because we're still going too aggressive. But hey, this is just kind of, for me, this is part of it. I'm not a machinist. I'm kind of learning as I go. Yeah, that's going to do it for tonight. We're going to get some rest, and probably in the morning we'll look at our cam design and our tools and kind of go through that, because we're starting to see that we're still too aggressive, which is, you know, got to think about it, because our test cuts are going better, but for whatever reason, when it's moving X and Y at the same time and it's trying to cut these profiles, we're not getting the same results that we did. Also, this is 4140. That other stuff is like 4340, so it's not exactly the same. So anyway, we're gonna call it a night and see what we can do tomorrow. All right, y'all take it easy.